Okay, so now let's try the second method, which is the secant method. So, yung second method natin is, okay. So, there are certain functions whose derivatives may be extremely difficult or inconvenient to evaluate. For these cases, the derivative can be approximated as a backward finite divided difference. So this method is similar to the Newton-Raphson technique. However, the second method uses a difference rather than a derivative. Okay? So the difference naman ngayon, hindi derivative. So this is the same sa Newton's method natin. So let's try an example. So use the second method to estimate the root of f of x equal to e raised to negative x minus x. Start with initial statements x sub negative 1 equal to 0 and x sub 0 equal to 1. Okay? So, first iteration tayo. Before that pala, how would we know when to stop? Okay, we are going to get the estimate root of our function. So, ang gagawin natin is to find the true root of this function through our calculator, shift solve. Okay, so if you input this on your calculator and press shift solve, okay, input nyo sa calculator nyo is e raised to negative x minus x equal to 0. And then press shift solve, lalabas dyan will be 0.5671432 and so on. Okay, so this is ngayon the true root. Okay, that is the true root. Now, we stop when the percent error, so percent error natin is this one, percent error is equal to the absolute value of our actual value minus the estimated value all over the estimated value times 100%. Okay? So this is the formula in getting the percent error. So kapag si percent error natin is very minimal na, we stop the iteration. Okay? So, first iteration natin at k equal to 0. So, si x negative 1 natin is equal to 0. X sub 0 natin is equal to 1. So, si f of x negative 1 is equal to, so ito, x sub k. Okay? So, si f of x negative 1 natin, if we plug si 0, okay, so if we plug si 0 dito sa ating function, we will get f of x raised to negative 1 equal to 1. And if we plug si 1 dito sa ating function, we will have f of x sub 0 equal to negative 0.6321. So we we round our answers to 4 decimal places. So our formula will be x sub 1 is equal to x sub 0 minus f of x sub k, and k natin is equal to 0. So, f of x sub 0 times x sub negative 1 minus x sub 0 all over f of x negative 1 minus f of x 0. Okay? So, plug natin yung mga values natin. So, x sub 0 is equal to 1 minus f of x sub 0 is equal to negative 0.6321. Okay? And then, our x sub negative 1 is 0 minus x sub 0 is 1. So, minus 1 tayo. All over x sub negative 1 is 1. And then, minus f of x sub 0 is equal to negative 0.6321. So, computing for this one, our x sub 1 is equal to 1 minus 0.6321 all over 1.6321. Okay? So, our x sub 1 is equal to 0.6127. Okay, si x sub 1 natin, 0.6127. Now, computing for the percent error 1, this is equal to actual value natin is 0.5671. Okay, minus our computed value, estimated value, that is 0.6127, all over our estimated, that is 0.6127, multiplied by 100%. So, our percent error 1 is equal to 8%. Okay, so masyado pang mataas. So, we still need to iterate. Now, for our second iteration, our k is now equal to 1. So, x sub 0 natin is equal to 1. X sub 1 natin is equal to this one, si 0.6127. F of x sub 0 natin is equal to, ayan, si negative 0.6321. For our f of x sub 1, so plug natin si 0.6127 dito sa ating function. So if we plug this one to our function, we will get negative 0.0708. So computing for x sub 2, okay, k plus 1, this is equal to, si x sub 1 natin, 0.6127 minus f of x sub 0, this is 0. Hindi, f of x sub 1, negative 0.078 times, that is 1, ito si x sub 0 natin, minus x sub 1, that is 0.6127, all over f of x sub 0, that is negative 0.6321, minus this one, negative 0.0708. So, computing for x sub 2, we will get, that is 0.5639. Ayan. And we compute for our percent error. So, percent error 2 is equal to 0.5671 minus our x sub 2, which is 0.5639, all over 0.5639 times 100%. So, our percent error 2 is equal to 0.56%. Although medyo mababa na siya, let's try another iteration and see if bababa pa ito. Okay? Kasi pag nangyari yon, we are closer to the true value sa true root niya. So, third iteration tayo. We have the third iteration at k equal to 2. Okay? So, x sub 1 natin is equal to 0.6127. X sub 2 natin is 0.5639. F of x sub 1 is equal to negative 0.0708. F of x sub 2 is equal to, if we're going to plug this dito sa function natin, we will get 5.0857 times 10 raised to negative 3. Okay, so now we compute for x sub 3. So, x sub 3 natin, x sub 3 natin will be si x sub 2, 0.5639 minus si f of x sub 2 natin, that is 5.0857 times 10 raised to negative 3. Okay, multiplied by our x sub 1, which is 0.6127 minus x sub 2, 0.5639, all over f of x sub 1, that is negative 0.0708 minus f of x sub 2, 5.0857 times 10 raised to negative 3. So, our x sub 3 is equal to 0.5639 minus 3 0.1160 times 10 raised to negative 3 minus 2.8678 times 10 raised to negative 3. So, distribute natin to dito. All over, we add this one that is negative 0.0759. So, our x cube, computing for that one, will be 0.5672. And if we are going to compute for the percent error, that will be 0.5671 minus 0.5672 all over 0.5672 multiplied by 100%, and we will get percent error equal to 0.02%. Okay, so this is very, very low. So, we stop our iteration here. Okay, so that is second method.